Okay, we're back. So, the first thing I need to say is that everything I'm going to say today is contained in the following handout, which I will start at the front. Now, on a high note. Okay, and that handout is also in PDF on the website already. So, right, now we're really going to start. So, I'm going to tell you about the information that you need to know in order to figure out what stats you need to go with a particular kind of research. So, you're doing a research proposal and also doing this critical appraisal group presentation thing. If you've got a particular research, you've got an experiment, there's some data, and you want to figure out what stats goes with it, these are the things that you need answers to. I'm not necessarily going to tell you how to answer all of these questions today, that's why there's 7 lectures, but I'm going to tell you what the questions are. And a couple of them we're going to have practice at making some of the decisions that go into these questions. So, the first important thing to say is that the purpose of statistics is to answer questions using data. Now that's not actually 100% true. It's actually a way of coping with variation. So statistics helps us to find descriptions and explanations for how things vary using the information from data. Okay, or possibly just theoretically describing how things vary. That's what theoretical statistics is for. So that means that we can use the whole field of statistics in places where things do vary. Okay, so people are not always the same. The same person is not always the same. If you measure the same thing on them multiple times, you'll get different answers. Things are not always the same when you measure them. They vary. And statistics is the science of variation. Okay, back to it. Okay, so point being though, we're going to use that science of how things vary to answer questions using data in situations where things are not always the same. But statistics is not good at answering all types of questions. It's only good at answering specific questions. And it's only good at answering specific questions where the data is specific as well. So there are whole other types of research, qualitative research, which hopefully someone's going to tell you about, which are designed for situations where the question is general or the data is general. So for example, if you wanted to know generally how elderly people feel in nursing homes, that's way too general for statistics to be able to cope with. We have to turn it into a specific question for statistics to cope. You could go to various nursing homes and interview old people and write down everything they say, and then you've got data, you've got information about them, but it's an interview transcript. And that's not specific enough for statistics to be able to cope. You have to turn the information you have into something specific to use statistics. Now you can use some qualitative research methods directly on the interview transcripts, and someone else will tell you about that. But today I'm telling you about a little bit about how to make your questions and your data more specific so that the statistics can cope. So the first thing you need to know is that it answers questions using data, as I said, and if you know the type of question you're asking, then you can choose what type of statistics you need to use. Okay, so on this side of the Prezi, we're going to talk about the question you're asking, and in a minute we're going to talk about the data. So at the moment we're going to talk about the type of question that you could ask and the 4 main areas of statistics. There are others, but these are the main ones. So this comes from my friend John O'Tuke, who is one of the lecturers in statistics, and he says that there are 4 main aims of a question in statistics. The aim could be to describe, it could be to decide, it could be to estimate, or it could be to predict or explain. Okay, and your question is about those sorts of things. But before I move on, I should talk about a little bit more about questions to do with statistics. So statistical questions are about concepts. They might be about a single concept, which is what this thing is about, where I have a concept and I just want to know more about it. So for example, is the median number of chapters in a novel, what is it? How much salt is there in an avocado? What percentage of children finish all their homework? One concept of chapters in a novel, concept of salt in an avocado, concept of finishing homework. One idea. Some questions, and in fact most questions in research, are actually about the relationship between 2 or several concepts. So are science fiction books thicker than other books? So that's genre and thickness are my two concepts. Does getting more sleep affect your grades? Amount of sleep and grades are the two concepts and how they're connected. Are women more likely to participate in volunteer work than men? We have the concept of gender and the likelihood of participating in volunteer work. They're the concepts that I'm trying to find that are connected. And almost all questions can be put into one of those two categories. We're going to get to that later again, but it will help us to understand this. So the first type of aim that I'm going to talk about is the aim of deciding. If you have a research question and it's a yes or no question, you are trying to decide whether the answer is yes or no. And when a statistician tries to decide the answer to a yes or no question using data, they will use a hypothesis test, which is where a p-value comes from. So if in research you see someone presenting a p-value, that means they have done a hypothesis test, which means they are answering a yes or no question. Okay? So it could be, is the median number of chapters in a novel 20? Now, if you don't know what median is, I will tell you, it's the middle, in the sense of half of the possibilities are below and half of them are above. And not just the possibilities, but half of all novels have more than 20 and half of them have less than 20. That's what it would mean if the median was 20. As opposed to average, which would be adding them all up and dividing by how many there are. Is your body temperature higher after a meal if the meal had chili in it? Does getting more sleep affect a student's grades, and are women more likely to participate in volunteer work than men? They're all yes or no questions. If you can frame your question as a yes or no question, then a hypothesis test is what you need to answer that question. Okay, on the other side of the coin, there is questions where you're trying to estimate. Okay, you're trying to find out what the number is. So if your question is of the flavour of what's this number, then you're trying to estimate a number. That's the aim of your question. And when statisticians attempt to estimate numbers, then what they will do is they will present a confidence interval. That's what the statistical object is that comes out when you're attempting to estimate something. That's what confidence intervals are for. And I'm talking about confidence intervals on Monday and what a confidence interval is and how it works. But I want to tell you that that's what it's designed to do. It's designed to answer a question where you're trying to figure out a number. So, every question that's yes or no, well, most questions that are yes or no, usually have a matching question that's about the size of a number. So the first question that I asked was, what is the median number of chapters? 20. And now I'm just saying, what is the median number of chapters in a novel? Okay, the other one I had a specific number and I want to know whether it was 20 or not. And this time I want to know what it actually is. If it's not 20, what is it? I asked before, is your temperature higher after a meal with chili in it? And now I'm asking, how much higher is it? Before I asked, how much of an effect is 30 minutes more... Before I asked, does sleep have an effect on your grades? Now I'm going to ask, how much of an effect does 30 minutes more sleep have, on average? And we've got to figure out what 30 minutes means. And how much more or less likely is a woman to participate in volunteer work than a man? Before it was, are they the same likelihood? And now it's, how much more? Okay, so if you're wanting to know a specific size, then that's what you're trying to do when you're estimating. The reason I put them next to each other on my screen, let's just test something, no. The reason I put them next to each other on my screen is because they use the same data. If you want to answer a yes or no question, you'll be using the same data as if you're answering a confidence interval question, usually. Okay? And they're really two sides of the same thing. You know, they're asking very similar questions, but slightly different in intent. One wants to know the size of a number, one wants to know yes or no. Oh dear. Okay. So, now I'm going to go back to the describe situation. I said earlier that statistics is not particularly good at answering general questions. Well, this is the attempt of statistics to answer general questions. If you just want to know what's going on, and you don't have a specific question, you don't have saying, is the answer 20, or what is the answer to this specific number, and you just have a vague question, that is what descriptive statistics are for. Okay, when you draw graphs, or graphs if you prefer, and basic numbers like calculating an average or a percentage, and that's all you do, you just calculate it and you tell everyone the average was 5, that is what this is for. You're just saying, what's going on? So instead of saying, you know, what's the median number of chapters, you're just saying, how many chapters do novels have, generally? You know, what are all the options? That's what we're asking, okay? What possibilities are there for body temperature after a meal? What sort of relationship might the amount of sleep a student have with their grades? what sort of things might be related to whether a person does volunteer work. They're just general. You're saying what might be related. You know, what are the possibilities? I'm not narrowing it down to a particular one. So if you've got a research question and you can't, and it's not specific at the moment, then this is what you'll be doing, descriptive statistics. The reason it's at the top of my picture is that you usually do it first, even before you've really got a handle on your specific question. So sometimes if this is the first time the research has ever been done, you don't have a specific enough question to ask, and all you can do is describe. And then based on what you see here in your graphs, you might say, now I have a specific question to answer. And it may just be that the same data can be used to answer that specific question, or it may be that you have to collect new data. Okay, and finally, there is this. There is the aim of predicting or explaining. And the type of question that you're asking is a what's the formula sort of question. You've got all this information about somebody, for example, and you want to figure out what it means in terms of some outcome. And I'll do some examples in a second. But the reason I put predict or explain is that they're the same thing. It's just that predicting is about the future and as explaining is about the present. You may want to say, I have a person, they have cancer. What is it about their past life that means they have what is the reason they have cancer now? Or I might say, I have a person now and they have all this information about them. Can I predict whether they will get cancer in the future? It's the same question, really. It's just that it's different in time. So we're trying to figure out some sort of formula. Okay, it's maths, that's what statistics is. There's going to be a formula. So how can I explain a person's body temperature after a meal using their temperature before the meal and the chili content of the meal? Presumably there'll be some formula that I put those two numbers into and it spits out what I would expect the temperature to be afterwards. How can I calculate a student's grade based on the number of hours of sleep during semester? Now, presumably it's based on other things too, but if I want to just sort of ignore everything else and say how much effect, how can I, knowing how much hours of sleep you've got, I can guess that your grade will be between, 20 and 50%. It's not specific, but at least you've failed. So how can I use a person's gender, age, income and religion to predict their chances of participating in volunteer work? And so presumably I can get some sort of formula where I can say if it's yes for gender it'll be a 1 and put all these ones and zeros in and it comes out with a probability. Okay, that's the idea behind it. So these are the 4 aims of statistics. There are other aims, but these are the ones that cover pretty much everything that you could want to do. And we're going to have practice at deciding what aim goes with what question, according to this activity here. So what I want you to do is look at these 30 research questions and decide which aim goes with which question. Please do talk to the people around you. Let's see if the microphone's back on. I'm going to get you to stop because we haven't got that long left and there's another activity to do in a minute. Here we go. Where's my upper light? And the focus. Okay, so the major moral of this is that it's never as simple as you think, right? So we need to think in your head, your decision of which of those it is based on what your aim would be if you were doing that research and what you were trying to actually say, and also the question itself. But let's just say, number one, does having chili in a meal affect your body temperature? Which one? Decide. It's a yes or no question. What percentage of people can distinguish between expensive and inexpensive wine? Estimate. Okay, I want to know what the percentage is. Now, technically you could think that's maybe describe, but it depends what you're going to say to the people who are asking you. I would say as well, before I move on, that all of these research questions are taken from research that was reported in the Body and Soul in the Sunday Mail newspaper. That's the best reference I can give because they don't give any of their own. So that's where they come from. So can the majority of people distinguish between expensive and inexpensive wine? Decide. I just want to know whether the answer is 50% or more or less. How much does taking a daily multivitamin change the chance of a heart attack? Estimate. What percentage of women drink more than 6 cups of coffee a day? Estimate. What are the possibilities for how many cups of coffee different women do drink per day? Describe. There's all the possibilities. You get the idea. The answers to this will be on the website. Okay? So, I'm going to skip that. I do have one last thing to say about this. We had some people say, well, you know, there was one, is it just estimate, or is it describe, or is it predict or explain? Okay, technically the ultimate aim of most research is to predict or explain. That's what the ultimate aim of most research is. But the specific question you're asking right now, at the moment when you're trying to do your statistics, might be to describe or to estimate. But eventually you'll get to a question that's actually what's the formula. And the final thing to say is that in order to decide your formula will have numbers in it that tell you how to do the calculation. And you're going to have to figure out what those numbers are. So you're going to have to do some estimation. You're going to have to decide whether one thing is related to something at all and whether it should be in the formula at all. That's a yes or no question. You're going to have to do some hypothesis tests. And even before you get to that stage, you're going to have to figure out what sort of formula it might even be by having a look at the shape of the graph that you see. And so you're going to have to do some descriptive statistics as well. That's why it's at the bottom. In order to do predict or explain, you're going to have to do all of these things anyway. And I'm going to talk about that next week when I talk about regression. And I'm also going to talk about the fact that sometimes you may have a decide question, a yes or no question, and the quickest way to answer it is to find the formula that goes with it. Okay, so in order to answer a yes or no question, you might do a statistical procedure. You might actually do regression, which is what the predicting or explaining is usually done with. You might do regression, even though that's reserved for predicting or explaining, because in order to do the regression, you're going to have to do the hypothesis test anyway. And when you ask the computer to do it, it will just tell you all of it, and it's the quickest way. So I will make more notes on that later. Right, so now we're going to move on and remind you again that the purpose of statistics is to answer questions using data. We talked about the question. If you know what type of question, you can narrow down your statistics to, hypothesis tests or regression and that sort of thing. And now we're going to ask more about our data. If we can know more about the data, then we can choose the exact statistical method that we need, or find out that we need to go to a professional statistician to create a brand new statistical method because no one's ever done this before. So, there are three general categories of question, and the first one is how is the data collected? You need to know the answers to this or you can't choose your statistics. So you need to know how the subjects were chosen. So a subject in statistics is whatever it is that you did your research on, whatever it is that you recorded information about. It's like subject in grammar. The subject of a sentence is the thing that does the verb. Okay, so if you did research on slices of brain, they are your subjects. If you did research on elderly people, then the elderly people are your subjects. If you did research and the information that you recorded was actually about the nursing home and not about the individual person, then your subjects are probably the nursing homes, not the people in them. Okay, so whatever it is that you wrote the information down about, they are your subjects. And you want to know how you chose them. Did you choose them randomly, or did you just choose the people that you happen to see today? You should be able to deal with the statistics in either case. One is usually better than another, but you just need to know. You need to know what is done to them. And if you're going to talk to a statistician, you need to tell them what was done, even if it requires you to explain how a mass spectrometer works, or explain how a particular drug is supposed to work. You're going to have to explain what's done to the subjects. What did you do? And when was the information recorded? So, did you hang the rats up by their tails to see what the effect of zero gravity would be on the blood rushing to their head? Okay, so which was done, right? It's real research. And when in that whole process did you record their blood pressure? Before, after, every 10 minutes with a probe that you stuck down their throat? Like, what did you do? And when was the information recorded? Before or after? All that information is important. You also need to know how much data you have. Do you record lots of different things per subject? Have you recorded temperature every 10 seconds? Or have you only recorded it once? Okay? Have you recorded age and gender and family history of cancer and ethnicity and whether they had toast for breakfast? Like, all these things, how many things have you recorded? Do you have lots of subjects or only a few? In general, lots is better, but it's important. Is there missing data? You follow people for 10 years to see if they get cancer and someone never comes back and you never find out what happened to them. That's missing data. Okay? All of that's important because it changes what you can do in your statistics. And finally, and most importantly, what are the variables in the data? So, you know how I said statistics was a science of variation? So when you record something, it's called a variable because it's not always the same. It's variable. So when you write down anything about a subject in research, that is a variable. It could be their name, it could be their age, it could be their gender, it could be their eye colour. Anything that you have written down about them is a variable. And you need to ask these questions about your variables. You need to know how to measure them. So suppose one of your variables is depression, you need to decide how to measure depression. Maybe there's some standardised test that they can fill out and it's a score out of 50. Maybe it's just severe, mild or none. Okay, you need to figure out how you're going to measure that and what you're going to write down in response, because what you write down changes what statistics you can do. The next is what type of distribution, what type of variable, I'm going to talk about that in a second. The next is what distribution it came from, I'm going to talk about that in a second too. And finally, defining groups or measurements. So, before I do any of this, I need to tell you this. This is how to organise data. Every time I talk about the fact that I'm going to do this talk with a statistician, and I ask them, what should I tell the medical students about statistics? And this is what they say I should tell you. Okay, they say you should tell them how to organise data. This is the one thing that the statistician wants you to know. Everything else, we can figure out later, this is what they want. Because if you get real data and take it to a statistician, if it's not organised like this, it's like hours and hours of work for everybody. So, this is how it works. Each person is a row. And each thing that you record about them is a column. So this person number 1 here, I've recorded their gender, their age, whether they had chili in their meal and what their temperature was. So this is the chili question. And I've recorded all their information in this row here. And this person, I've recorded all their information in this row. And this person, I've recorded all their information in this row, and so on. Rows for the subjects, columns for the people. And they also say, please make it consistent. So if you're going to say gender, don't say male and female and woman and man and M and F and capital M and small f. Just make it consistent, do the same thing every time. I helped someone with their research and they were recording season, and they had spring, and spring with a capital S and spring with a space after it, and sping. Okay, so make sure it's consistent, because the computer's not clever enough to tell the difference. All have to be the same. And that's really what statisticians want you to do. Okay, know that and it will help. But it's also useful to know that that's what the data looks like, because it can help you make your decision later of what to do. Okay, a variable is something that you record. And this is the thing that I want to get onto today. The other stuff I'll talk about again. There are 2 main flavours of variable. There are the numerical or quantitative or scale or interval variables. And those are just what people call them in different disciplines. Statistics tends to be spoken in its own dialect. The book that I normally reference, which is called Medical Statistics at a Glance, is they call them numerical variables. But you might also hear them as quantitative or scale or interval. Basically, they're numbers. Okay, they are numbers. And how far apart they are means something. You can say that somebody's temperature is 1 degree hotter than somebody else. Okay, that's what numbers are. The other main flavour of variable is your categorical variable, and some people call them qualitative variables. And they're generally words. They can be numbers, but in general, they're words because it doesn't matter how... You can't calculate how far apart they are. So male and female, there's no distance between them, they're just different. And shoe size, 11 is definitely less than 12, but it's not 1 less than 12 because it's not the same as the difference between 10 and 11 with shoe size. Okay, so how far apart they are doesn't have any real meaning. Okay, so that's how to tell if your number is really a number or if it's just a category. And we're going to have practice at this in a second, so it will make sense more. I should let you know that there are 2 sub-flavours of numerical and categorical variables. There's continuous variables, things that you measure, like temperature or height or lung capacity. And there's discrete variables that you count, such as the number of sores that someone has, or the number of colonies of bacteria on a dish, or how many students there are in a class. They're counted. They can only have certain numbers. You can't have 1.5 people. Okay, so no one really in general cares, because the statistics is usually not different depending on those things. Okay, so those things don't matter. I need to say them because in most medical research, when they say continuous, what they mean is numerical. Okay? So they won't use numerical, quantitative, scale or interval, they'll say continuous. There are 2 flavours of categorical variables too. There are the nominal variables, where they're just names, more or less has no meaning. So gender, male or female, we're not going to say that one of them is more or less than another. Eye colour, brown is not more than blue, it's just different to blue. Okay? Dewey Decimal Number in the library. You know, 999 is not more than 998, it's just different. It just represents a different category of knowledge. Okay? And some of them are ordered, more or less has a clear meaning. Steak doneness, like rare is less than well done. Okay, but they're coming in order. Okay, and also the SELT that you might fill out at some point. You do a survey and it says, you know, is David clear in his explanation? Strongly disagree to strongly agree. That's ordered, but they're not really numbers because the difference between 6 and 7 is not the same for everybody, and it doesn't necessarily mean anything. It's just ordered, but they do come in order. Most people will not say those things, but they might say nominal or ordinal. No, it's categories. Right, we're going to have practice at deciding what type of variables we have. Because this is... Yes? Here we go. Many of you have noticed that some of them might be a bit ambiguous, and that's important because sometimes it is ambiguous, but you're going to have to make the decision anyway if you're going to be able to choose what stats goes with what. So whether a person can distinguish between inexpensive versus expensive wine. Categorical. It is yes, they can, or no, they can't. Okay? How often a person takes a multivitamin? All right, so someone who said numerical, tell me why. You get what sort of number? Are you saying number of times a week or something? Yes. Is that what you mean?
Yes.
Okay, so if you record it as number of times a week, numerical, sure. But what if you just ask them a survey and ask them to tick boxes of like, you know, never, rarely, often, or yep?
The underlying variable is
No, the variable we have written down. We're not talking about the underlying variable Ty, thank you very much. The variable that we have written down, not trying to make you embarrassed, the variable that we have written down is categorical if you've written it down that way. But Ty makes a very important point. If it's possible to record it as a numerical variable, then it's probably a better plan to do that if you can. Okay? So if it's possible to write it as, give me a strict number of cups of coffee a week, since it is a number, as he says, the underlying variable, it's probably best to do it that way. But if you've recorded it as just words, then you've got no hope, it's categorical. So this depends on how you've done it. The number of cups of coffee drunk per day is most definitely numerical. Whether more than 6 cups of coffee are drunk per day. Categorical, it's yes or no. Okay, someone asked me, so are there any that you're worried about? Yep. IQ. A person's IQ score. Now it's normally out of what, 200? Isn't it? Oh, who knows? It's out of 200, isn't it? Anyway, it's out of quite a big number. It's probably okay to consider that as a numerical variable. Technically, IQ is the number of questions you get correct, adjusted from this test. Now, whether it actually represents intelligence is a whole different question. But the score on that test is definitely a number. So it's probably okay to treat it as such in the statistics, and the psychologists would stress that they can, because they keep doing it. Yes?
If you did a survey and asked what IQ is it low, medium, high, is that
Then it would be categorical. Okay, if you ask someone if your IQ is low, medium, high, then it would be categorical. Yep? Yep. So someone's asked another question. If you give ranges, if you ask someone's age, for example, and you say you 0 to 10, 10 to 20, that's a bit ambiguous, but and 20 to 30, it's categorical. Okay, because you don't know what their actual age is. So if you can, you would ask their actual age. That's the best plan. Okay, because you can always put it in categories if you need to, but you can't go backwards. You can't take it from categories and figure out their actual age. So this is all an important point. Okay, how you record it changes what type of variable it is, and that changes the statistics you can do. Last one, the change in body temperature is numerical if you actually figure out the actual difference in temperature, like in terms of a number of degrees. I didn't mean whether it changed, which would be categorical. Okay? So, and level of satisfaction is actually categorical because it's out of a small number. Except that problem is that it's probably okay to actually treat it as a number if you've got enough people. So if you're confused about which one it is, err on the side of recording it as a number if you can, and then talk to a professional to help make the decision. Okay? Right, so back to the screen because we've got about 5 minutes. And this is what I'm getting to now, and I was just mentioning it. If you've got numerical data, or quantitative if you like, you want to know about the distribution. So when a statistician says the word distribution, they mean how the possible values are spread out. So distribution means all the possible values and how likely every one of them is. So with numerical data, it could be approximately normal, this lovely hump shape, in which case what they call a parametric test would be fine. So if you ever read research and it says they did a non-parametric test, it means that their data wasn't normal usually, and they couldn't do the usual things that you're allowed to do with lovely hump-shaped normal data. If your data's skewed, like this, or worse, like this, then you might need to do what they call a non-parametric test. And I will talk about these things later, okay? But I'm telling you about the decision-making process. You've run through the decision so far and you've said, I've got my question, I've got my variable, I've figured out how I wrote it down so I know what type of variable it is, and now I know it's numerical, I'm going to look at the distribution and that's going to tell me whether it's a parametric or non-parametric test. And the last thing is your Likert scale, which is the word that we use for those things of satisfaction out of 7 from strongly agree to strongly disagree. A non-parametric test will probably not work on a Likert scale, because most non-parametric tests are based on the assumption that people can't give the same answer. And in a Likert scale, you'll get like 50 people with the same answer. So it's probably, you will either have to pretend it's numerical and treat them as numbers, or lump them into a smaller number of categories and treat it as categorical. I say this now, it may not make sense now, but I have said it. So sometime in the future, if you ever come to talk to me about your stats, I can say, do you remember what I said in 2013 about Likert scales? And you'll say, yes, of course I do, David. I remember everything you've ever said. And then you'll say, oh, of course, I can't use a non-parametric test. Thanks, David. Okay? But, final thing is, this probably doesn't matter if you have heaps of data. If you've got 200 people in your sample, the fact that it's skewed is probably 100% irrelevant. Okay, because most of these tests that the statisticians design work pretty well even if it's badly shaped data if you've got enough people in the sample. Okay? Where the cutoff is between it matters or it doesn't matter is open to discussion, and that's the sort of thing you will talk to a professional about. And there is one last thing in the last minute, what the categories define. So I've talked about the numerical variables. Now I'm going to talk about the categorical variables. So I'm going to talk about the Chilli example. There are two possible ways I can think, to start with, of designing my Chilli experiment. So this first one is that I get my friends and I give them all a Chilli meal and then I measure their temperature. Okay, assuming that their temperature was roughly 37-ish to begin with. I give them all a Chilli meal, and some of them I give them a non-Chilli meal, and I measure their temperature as well. So what I actually have here is two separate groups. So this is the data. Those first two people are the yes Chilli group, and the second two people are the no Chilli group. I've got two completely separate groups. My chilliness, yes or no, has defined two completely separate groups of people. One group had the chili, and one group didn't. That's what we call independent groups. Okay? And I just denote this with this picture where I have each person, and the outcome of the temperature has only been measured once per person. Each person's only got one measurement of temperature. The other thing I wrote down about them, which was the chili, was which group they were in. So it doesn't really count. It still counts as a variable, it just doesn't count for my decision. This situation, I get my friends, and I get them all to have a chili meal on one day and a non-chili meal on a different day, and I write down the temperatures for both. I've written down their temperature twice for everybody. So now my data looks like this. Person 1, I've written down their temperature with chili and their temperature without chili, and I've written down the temperature with chili and without chili for the second person. Look, everyone's got two measurements of temperature. My yes for chili gives me a whole variable. It's the temperature with chili. And my no for chili gives me a whole separate column. So what my temperature, what my chilliness has done, has told me that I have two measurements on every person. So that's what they call repeated measures, or matched pairs, if there's only two. So let me go over that again. Sometimes your categories and your categorical variables will define completely separate groups, one group for each of the possible possibilities. Sometimes it'll tell you that you've measured everybody 2 times or 3 times. So whether your situation is you've measured your outcome twice per person or once per person and you get 2 different groups is important. And I'm going to go over this again in lecture 4 because it needs some more discussion. But this is all the information that you need to know about your data to get to the final question. So here it is. You need to know your question, you need to know your data, and once you've got all that information together, you'll be able to know your stats. And this is a picture of everything that we've done. See, in this situation, we have a categorical variable that's forcing changes in a numerical variable. That's my relationship that I'm interested in. It's a decide sort of question. My numerical variable is normal, and my categorical variable defines independent groups. Once I have all that information, I can choose what stats to use. Okay? And we're going to have some practice at choosing what stats goes with what research in lecture 4. But for the next 2 lectures, we're actually going to be talking about what a hypothesis test is, what a confidence test interval is, and what regression is, so that you can have more power over your statistics by having more knowledge, because knowledge is power. Okay? So I'll see you on Monday, hopefully. Thank you very much.